Welcome in this screencast about maths for robotics, in which we look at the end position of a robot arm. So let's start with a base frame. Base frame consists of a x-axis and a y-axis. So we have the x over here and the y there. Say we have a robot arm 1 and the robot arm 2, and the length of the robot arm is called alpha 1, length of the robot arm 2 is called alpha 2, in this way. So we need two angles as well, so this angle is theta 1, and when we prolong the first robot arm we get the second angle over here, theta 2. So the question is, what is the position of this point? Okay, let's start first. Give letters to the point. Say this is origin, this is point A, and that would probably point B. So the point A has a x1 coordinate and a y1 coordinate. So what are those coordinates? Well, if you look at this triangle, you could say that the x1 equals the length of the arm, alpha 1, times the cosine of theta 1. When you have here the cosine of this angle is this underlying rectangle side divided by the longer side. On the other hand, the I1 would be the length of the robot arm alpha 1 times the sinus theta 1. Okay, now we look at point B. Relative to the horizontal, we have the theta 1 angle over here. So this angle of the second arm relative to the horizontal would be theta 1 added by theta 2. So what we get is the x2. The x2 is actually the x1 added by the length of the second robot arm, which is alpha 2 times the cosine of these two angles, theta 1 added by theta 2. When I write it out, I said, okay, x2 is the x1 is this one, put it in over there, so we have alpha 1 cosine theta 1 plus a alpha 2 times cosine theta 1 added by theta 2. Well, have a look at the y coordinate, so we call this I2, and we have y2 is the I0, y added by the length of the robot arm 2 times, in this case, the sinus, it's this side, so we have a sinus theta 1 added by theta 2. Okay, we fill in this I1 over there, and we have y2 equals alpha 1, length of the first robot arm, times sinus theta 1 added by alpha 2 sinus theta 1 added by theta 2. So these are the two equations, so this one and that one. Okay, now we need to do this in practice. Say we have a alpha 1 is alpha 2, we make them 1, and we say the theta 1 equals 20 degrees and the theta 2 equals 30 degrees. What would we get? Well, say the x2 is alpha 1, which is 1, so we have cosine 21, so we have a cosine 20 degrees added by, well, probably this length is 1 as well, so I have added by cosine 20 degrees added by 30 degrees. So this is not more than cosine 20 degrees added by cosine 50 degrees. And when we fill that one in, we get x2 equals, well, the cosine is something like 0.9397 added by cosine 50 will be something like 0.6428, and we get a 1.5825. So this coordinate here is 1.5825. We do the same thing for this coordinate over here, the y. So I have a y2 equals the sine of 20 degrees added by the sine of 50 degrees. Well, that will be something like sine of 20 is 0.3420 added by the 50. 0.7660 is 1.1081. So this is 1.1081. Okay, so we have two robot arms, the links with given lengths, given angles, and we can calculate the coordinate of the endpoint B. Thanks for watching.